A mineral is defined as any naturally occurring inorganic solid that has an orderly crystalline structure and a well-defined chemical composition. Naturally occurring elements are also considered minerals. Minerals are classified according to their characteristics and formation.
There are a few foundational criteria which must be met in order to classify something as a mineral. A mineral must occur naturally, it must be solid, it should have a repetitive atomic structure, and the chemical makeup of the mineral should be consistent. These criteria give a good description of what comprises the general structure of minerals.
When thinking about the chemistry of minerals, however, we begin to consider atoms, the elements that ultimately determine the structure and existence of each mineral. The chemistry of a mineral also contributes to its classification.
The primary components of chemistry to understand here are that an anion is a negatively charged atom, a cation is a positively charged atom, and a polyanion is a strongly bound group of atoms consisting of a cation and multiple anions, which produces an overall net negative charge.
Minerals are generally divided into two groups: silicate-containing and non-silicate-containing minerals. Silicate minerals are the largest group of minerals found on Earth. They comprise around 90% of the Earth's mantle and crust. Among these, feldspar is the most common, followed by quartz.
All silicates have the same fundamental structural basis, the silicon-oxygen tetrahedron. This tetrahedron is made up of 4 oxygen atoms which surround one smaller silicon atom, making them a polyanionic group. The tetrahedrons of different minerals may be joined in different ways and have different internal structures. Bonding of a silicon-oxygen tetrahedron underpins all minerals in the silicate mineral group.
Cations, which will commonly bond with these tetrahedra, forming ionic mineral components, such include ferric and ferrous iron, calcium, potassium, and sodium. Another important terminology when considering minerals and their makeup is polymerization. A polymer is a substance made up of repeating chains of molecules. Polymerization is the name of the reaction that creates a polymer.
There are different types of polymerization. The silicon-oxygen tetrahedron is sometimes shown with a small dot at the end of it. This dot indicates that there is a dangling bond, or free valence electron, that another element or molecule can attach to. Silicate minerals are divided into subgroups based on the degree of polymerization of the silicon-oxygen tetrahedra in the overall polymer. Depending on a number of factors, the silicon-oxygen tetrahedra can combine with tetrahedra of other minerals in numerous configurations. Further, the structure of a mineral determines how it will cleave and split into fragments. Silicate minerals are most commonly formed throughout the cooling of molten rock at the Earth's surface or within the mantle.
Non-silicate minerals are found in far less abundance and comprise of some of the most well-known and valuable minerals. Despite them only accounting for 8% of the Earth's mineral types, non-silicates are important and commonly used, playing a large role in our everyday lives. Limestone is comprised of calcite-rich sedimentary rock used as building stone, road aggregate, and in some cements. Most of us use halite every day. It is also known as sodium chloride or common table salt, while gypsum is a commonly used building material. It is worth noting that different types of minerals combine and interact to form rocks. Rocks are classified according to how they have been formed and fall into the categories of igneous, formed by fire; metamorphic, formed by the transformation of existing rock; and sedimentary, formed by the assemblage or laying down of mineral particles. Some of the most commonly used types of rocks are a product of the combination and interaction of well-known minerals. Granite, sandstone, and gneiss are all seen frequently throughout the buildings and ornaments of our architecture.